So suppose A is a set of vectors, let's say 2, 1, and 1, -2. Is that what I want? Let's put 1, -1, right? That's easy. Let's do that. Now, one can show that A is a basis for the vector space R2. Okay. So we're thinking of the usual plane as the vector space, and this is the vector space for R2. Now, one question is, how do you know that's a basis? Well, first of all, I know that these two are linearly independent. How do you know that these are linearly independent? Well, okay, so maybe I should do this first. If you just have one vector as a list, then it's always linearly independent, right? Because there's no other vector to represent this by, except for the zero vector. If you have a zero vector as a single list, that's not linearly independent. Okay? But any non-zero vector, if you just have one of them, it's linearly independent. Okay? Now, if you have two vectors, how do you know it's linearly independent? What's linear independence again? If one vector cannot be represented as a linear combination of the other ones, right? So can this be written as a linear combination of this one? Well, you just have one single vector, so saying that this is a linear combination of this simply means this is a linear multiple of this. It's a scalar multiple of this. Is this vector a scalar multiple of this? No. They're pointing at different directions, right? So there's no way that this could be a scalar multiple of this, nor the vice versa, okay? So that's like an intuitive way of directly seeing that these two vectors are linearly independent, okay? And if you have three vectors, then graphically they should not be coplanar. If they belong to a single plane, then you know that these are not linearly independent because you can represent this third vector by a linear combination of the two. Yeah?
So if you have two vectors, we can always make that assumption that if they are not scalar multiples,
Yeah, then
they're not.
they're not linear.
Okay.
They are linearly independent. They're not linearly dependent. Right? Of course, when it comes to formally proving it, you should actually say A times this plus B times this equal to the 0, 0 and solve it and show that the only way that could happen is when both A and B are 0. That's how you prove it. And because these form a square matrix, if you put them together, another way of doing it would be to use the determinant. You can use the determinant trick only if it's a square matrix. And of course, if you put it here and then you do AE minus BC, you see that it's -3. Negative 3 as the determinant. So it's non-zero, so it's linearly independent. So that's another way to show that's linearly independent. Okay, so, and then if you know that this is linearly independent, and then what's the dimension of R2? Dimension 2, right? So if you have a list of length 2 that's linearly independent, that should span everything in the vector space. Does it make sense? Yeah. This is a basic intuition of vector spaces that you must have. If you're given an independent list of the right length, then which is linearly independent, then it has to be the basis. Okay? So we know that that's a basis. And let V be the following vector, say 3, 5. It's a vector in R2, right? So you have a vector in R2, and now I'm going to give you an assignment, which is to find V A. guess I can't ask you to do this because you don't even know what this symbol means. So this means, let's see. Right. So this means if this is A comma B, this means B is equal to A times 2, 1, and B times 1, negative 1. That's what this means. Okay, so let's figure out what that is. 3, 5, I'm trying to represent 3, 5 as a linear combination of 2, 1, and 1, negative 1. So that means 2A plus B must be 3, and A minus B must be 5. Add them up, we get 3A equals to 8, so A must be 8 over 3. Plug it back in here, and solve for B and say 8 over 3 minus 5 must equal to B, so negative 7 over 3 will be your B. So we just have figured out that the matrix V, if you use A, that gets represented as AB, which is 8 over 3, comma, negative 7 over 3. And the claim that this is a basis means that any vector, I can put any two numbers here, and you can always come up with two numbers A and B that would make them equal. Okay. Any vector in the plane can be written as a linear combination of these two vectors.